Hello everyone, welcome to our video. Today I get Mayank Singh, initiator of this idea,
And I get Narendra Pakala, the supporter of this idea, representing from Sainik School Imphal.
Today we are here to explain our idea, that is laser pointing distance measuring tool. A very simple tool or an idea. This is like a solution for a very common problem which we have seen in today's life of a student. Whenever a student wanted to measure a distance of a nearby object or a far object, he used to measure it through simple components or simple tools such as scales or inch tape, and which is not a convenience way, since if he wanted to measure it, there will be involvement of human error also at that position. So it will reduce the accuracy of that particular result. And students are not just wanted to measure the distance, they are having their project work, demonstration or practical work. In that cases, if there will be a lack of accuracy or reduced accuracy, then it will overall degrade the result of the project or demonstration. At that time, we need a convenience way or a more precise way to calculate the distance of whether near object or a far object. And even while students are measuring a far object, they have to have a physical contact at that area. I suppose they have to measure it through inch tape, so they have to approach to that particular area. But what if they are having an inaccessible object to measure? So at that time, this will make huge difficulties for the student to measuring the distance with accuracy and accessibility. In order to avoid all this problem and overcome this main difficulties, we have come up with our idea, that is again laser pointing distance measuring tool. Let me give you a brief explanation of what our tool is have to work. Here is the side view of our tool. We having two components there. You can see these are a pair of a mounted laser on a shaft of a rotary encoder which will act as an angular sensor. Our project is simply based on the concept of straight lines, angles and trigonometry. So here I am using the trigonometry and straight line formula. So let me explain you how it's work. Whenever I move the laser, it will move the shaft of the rotary encoder since it is mounted on that. So that's how it will able to detect the angles. So what is the importance of this angle in this our project? Let me show you. Let's suppose there is an object here. I strike a beam on the object like this. Let's suppose this point. At this point I strike it the beam. Now at second position I have again coincide the beam or coincide the point like this. Means I align two lasers on a particular point in order to get at that point as a coincide point on that particular desired object which distance I wanted to know. Since we have aligned our lasers in such a way, it will make some angle with our reference line, that is x-axis. Oh, before that I forgot to mention you how they are placed. There is a reference line, this is a reference line, that is x-axis, in where there are the pair, these two pairs have placed. One is at origin and one is at any point on x-axis. So it will make some angle. You can see there is a triangle formation, right? So it will make some angle with x-axis like this. So like suppose alpha and beta. So we just need to measure that angle. And after computing a trigonometric formula which I have developed with the help of straight line concept, we will able to get the perpendicular distance of this object to this x-axis, means our reference line. That is our main core concept.
Now I here will be explaining you this complex idea in a little brief, in a nutshell. This is the top view as you can see here. These two big lasers are the same as the one given in the side view. The lasers will be pointing at an object which will be placed somewhere over here. The lasers, where the point they are meeting, from that to the reference line, will give you, this device will give the distance of this dotted line. And
so furthermore going about the functioning and components. To control this whole process, we having a microprocessor known as Arduino Uno, and we have made some circuit since we having a LCD over there. Oh, sorry. Having a LCD over there. You can see here. So the main role of this LCD is to display the results along with the angles, measure angles. That is means the result is about the perpendicular distance and with the measured angles. And that's how we will able to, just by aligning two lasers or two things in a particular point manually, we will able to get the distance of any object, even an inaccessible or far object. So now let's go for a simple demonstration of our simple or partially working model. So again guys, here is having a partially working model. Since I don't have the laser here, so I'm going to explain you how it's work only. Although you are not able to see in the what's happening on the screen, I will describe you. There is a three components or three variables over showing on the screen, where in corresponding to that there are some values. They are the values which are involving the distance measuring, as you can see. So yeah, here the A represent the angle made by the that pair means the laser with the reference line x-axis, and at the angle B is the second pair angle measure or made by the x-axis. As you can see, as I am moving this shaft of the rotary encoder, which is our angular sensor, it's sensing some angle. You can see the change in B, and in A also you can see that some changes, and along with that you can see the changes which is going on the corresponding side of R. Here R is our distance or result which are showing, and it is also going out like this. But it doesn't mean that it is going to describe you correct distance. If you're not able to align the laser point or beam on a particular point, then you will not able to get the correct distance, because it is just showing what we have calculated. I provided a formula, and using the angles, measure angle, he is giving the results. So that's how. By simply applying the application of trigonometry and straight line in a common way or technical way, we will be able to generate such a beautiful idea and a complex problem solving, where students are not able to generate the accurate results of their distance, but now they will be able to do it. So it will not only help the student in order to get away from this problem, but it also inspire the student how they will able to convert their theoretical part in a practical way, means application.
Imagine a small device with just two lasers pointing at a common point that will give you the distance between the object and the lasers. This is our idea. This will not only help the students in developing their projects or in practical fields, but it will also help engineers, builders, and in many surveys and etc. This will be very helpful in the future.
So thanks a lot for watching this video.